Now, in this lecture, we will find out the value of angle ADC using two different methods. In the drawing, we have triangle ABC. We know that angle ABC equals to 30 degrees. This angle ACB equals to 100 degrees. And we also know that AD equals to BC, and we want to find out the value of angle ADC, the value of this angle ADC. So we start with the first method. In the first method, we'll define side AC of triangle ABC as A, that is to say the length of AC is equal to A units, and we will define side BC of triangle ABC as B, that is to say BC equals to A units in its length, and according to what is given us in the question, we know that AD equals to BC, AD equals to BC, and according to our definition, BC equals to B units. So from this equation, we will derive that AD also equals to B units. AD equals to B units. So we write here that AD equals to B units. In the next step, I will present to you a new law that is actually the law of sines. According to the law of sines, the law of sines is true in any triangle. So you can write down that in any triangle, so if we have a triangle ABC that could be any triangle, so this is triangle ABC. This is triangle ABC that could be any triangle. And we know that side BC of triangle ABC equals to A units in its length. This is angle A. Side AC of triangle ABC equals to B units in its length. This is angle B. And we also know that side AB of triangle ABC equals to C units in its length. And this is angle C. Then according to the law of sines, A over sinus A equals to B over sinus B, that equals to C over sinus C. And this law is true in any triangle. So from this formula, again, A over sinus A equals to B over sinus B equals to C over sinus B. From this formula, we will derive that A over sinus A equals to B over sinus B. So we will implement the law of sines in our drawing. Here I will copy triangle ABC in a new page, and we will implement the law of sines in this triangle ABC. So I copy triangle ABC in a new page. So this is a triangle ABC. So this is triangle ABC that I copied from the original drawing. We know that side AC equals to A units, side BC equals to B units, and angle BAC is the missing angle, so we will define it as angle X. We know that in triangle ABC the sum of the angles must be equal to 180 degrees, so that is to say angle X plus 30 degrees plus 100 degrees must be equal to 180 degrees. According to the law that the sum of the angles in any triangle is equal to 180 degrees. So here we will subtract 130 degrees from this equation and we will get that angle X equals to 180 degrees minus 130 degrees, it equals to 50 degrees. So we found out that angle X is equal to 50 degrees. We will substitute angle X by 50 degrees. In the next step, we will implement the law of sines in this triangle, triangle ABC. According to the law of sines, A over sine of 30 degrees equals to B over sine of 50 degrees. I will repeat again, according to the law of sines, in triangle ABC, A over sine of 30 degrees equals to B over sine of 50 degrees. Here we will divide equation number 1 by B and then we will multiply it by sine of 30 degrees and we will get that A over B equals to sinus 30 degrees over sinus 50 degrees. I repeat again, according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. So actually, we found out that this angle, that is actually angle BAC equals to 50 degrees. Therefore, if we define angle BAD as theta, then angle DAC will be equal to 50 degrees minus theta because of the fact that the sum of the angles must be equal here, must be equal to 50 degrees. So angle theta plus 50 degrees minus theta equals to 50 degrees. So we found out that angle DAC must be equal to 50 degrees minus theta. We will define angle ADC, that is actually the angle that we are looking for as angle Y. And we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So that is to say, in triangle ADC, angle Y plus 100 degrees plus this angle that is 50 degrees minus theta. In total, the sum of those three angles must be equal to 180 degrees. I will repeat again. In triangle ADC, the sum of the angles must be equal to 180 degrees, that is to say angle Y plus 100 degrees plus 50 degrees minus theta must be equal to 180 degrees. Here we will subtract 150 degrees from this equation, and we will get that Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add to this equation angle theta, and we will get that angle Y equals to 30 degrees plus theta. So we found out that the angle that we are looking for, that is to say angle Y that equals to angle ADC, equals to 30 degrees plus theta. So we substitute angle Y by 30 degrees plus theta. In the next step, I will copy triangle ADC in a new page, and will implement the law of sines in this triangle ADC. Okay. So this is triangle ADC that I copied from the original drawing, and we will implement the law of cosines, the law of sines in this triangle ADC. So according to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 50 degrees. This is actually, it is not B. I made a mistake. It is not B. Actually, B is BC and not DC. This is not B, but AD equals to B. AD equals to B, and this is not B. So A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. So here we will divide this equation number 2, by B, and then we will multiply it by sinus 30 degrees plus theta, and we will get that according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. I will repeat again. according to equation number 2. In triangle ADC, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. And we have already found out that according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. So we can create here equation number 3 that states that A over B according to equation number 1 equals to A over B according to equation number 2. Okay, so according to equation number 3, we will get that A over B according to equation number 1, that is actually sinus 30 degrees over sinus 50 degrees, equals to A over B according to equation number 2, that is actually sinus 30 degrees plus theta over sinus 100 degrees. Okay. Here we will cross multiply this equation, equation number 3, and we will get that according to equation number 3, we will get that sinus 30 degrees is 1 over 2 times sine 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. So here we will use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. We'll use this trigonometric identity for sinus 100 degrees, and we will get that 1 over 2 equals 1 over 2 times 2 sine 50 degrees cosine 50 degrees according to this trigonometric identity. Sinus 100 degrees equals to 2 sine 50 degrees cosine 50 degrees, that equals to sine 30 degrees plus theta times sine 50 degrees. So here we will divide, first of all, 2 over 2 is 1, so 2 will get cancelled. And we have here sine 50 degrees on both sides of equation number 3. So sine 50 degrees will get cancelled. And what is left from equation number 3? What is left is actually cosine 50 degrees equals to sine 30 degrees plus theta here we will use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. We use this trigonometric identity for cosine 50 degrees, because cosine 50 degrees, according to this trigonometric identity, will be equal to sine 90 degrees minus alpha is 50 degrees, so it is sine 90 degrees minus 50 degrees, and 90 degrees minus 50 degrees is 40 degrees. So we actually got that cosine 50 degrees equals to sine 40 degrees. We found out that cosine 50 degrees equals to sine 40 degrees. So according to this equation, we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees. So we'll do it now, and we'll get that cosine 50 degrees is sine 40 degrees, and it equals to sine 30 degrees plus theta. So we got that sine, according to equation number 3, sine 40 degrees equals to sine 30 degrees plus theta. From this equation we will derive that 40 degrees equals to 30 degrees plus theta. Here we will subtract 30 degrees from this equation, equation number 3, and we will get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees, and here the angle that we are looking for, it is actually angle ADC, and angle ADC equals to 30 degrees plus theta, and theta equals to 10 degrees. That is to say, angle ADC equals to 40 degrees. So we actually found out, according to the first method, that angle ADC equals to 40 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle ADC according to the second method. So, in the second method, first of all, we will define side BC of triangle ABC as A. That is to say, the length of side BC equals to A units. BC equals to A according to our definition. And because of the fact that BC equals to AD according to what is given us in the question, from one side, and from the other side we define BC as A. From this equation, A equals to BC equals to AD, we will get that AD also equals to A. AD equals to A, so we can write here that AD equals to A. And in the next step, we will extend side BC of triangle ABC by a straight line. And then from point A, we will draw perpendicular to the extended BC. So actually, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the intersection point between the perpendicular from point A and the extended BC as point E. We will define line segment AE as Y, and we will define line segment CE, this line segment, as X. And we will find out the value of this angle, angle ACE. We will define it as Y. We know that BC, it is one side of triangle ABC, therefore it is a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that it must be also a straight line. So BE is a straight line. I write it down. BE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. So which angles we have at point C on the upper side of BE? We have 100 degrees plus angle Y. In total, they must be equal to 180 degrees. I will repeat again. We know that BE is a straight line, and the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of BE at point C? We have 100 degrees, and we also have angle Y, so the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Here we will subtract 100 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 100 degrees, it equals to 80 degrees. So angle Y equals to 80 degrees. We can write here that angle Y equals to 80 degrees. So in the next step, we will focus on the right triangle, triangle ACE. So actually, in the right triangle, triangle ACE, we know that tangents 80 degrees equals to AE over EC. I will repeat again. In the right small triangle, triangle ACE, we know that tangents 80 degrees equals to AE over EC. But AE equals to Y according to our definition. So we'll substitute AE by Y. And EC equals to X according to our definition also. So we actually found out that according to equation number 1, tangents 80 degrees equals to Y over X. Here we will multiply this equation, equation number 1, by X, and we will get that y equals to x times tangent 80 degrees. Okay, y equals to x times tangent 80 degrees. So in the next step, we will focus on the right triangle, triangle ADE. This right triangle, triangle ADE. And first of all, we will define the missing angle, angle ADE, is angle theta. It is actually the angle that we want to find out. So it will be equal to angle theta. And in the right triangle, triangle ADE, we know that sinus theta will be equal to AE over AD. I repeat again, on the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. So, but we know that AE equals to Y and AD equals to A according to our definition. So in conclusion, we found out that according to equation number 2, sinus theta equals to Y over A. I'll repeat again. According to equation number 2, sinus theta equals to Y over A. Here we will multiply equation number 2 by A and then we will divide it by Y. We will get that according to equation number 2, A equals, actually we multiply it by A and then we divide it by sinus theta, so A equals to Y over sinus theta. But we have already found out that Y, according to this equation, equation number 1, equals to x times tangent 80 degrees. So we'll substitute Y in equation number 2 by x times 80 degrees, and we will get that angle A, according to equation, that A, according to equation number 2, equals to Y, that is x times tangent 80 degrees over sinus theta. I'll repeat again, according to equation number 2, A equals to x times tangent 80 degrees over sinus theta, and Y, according to equation number 1, equals to x times tangent 80 degrees. In the next step, we will focus on the triangle, the right triangle, triangle ABE. On the right triangle, triangle ABE, sinus 30 degrees, actually it is tangent 30 degrees, tangent 30 degrees equals to AE over BE. I will repeat again. In the right triangle, triangle ABE, we know that tangent 30 degrees equals to AE over BE. According to our definition, AE equals to Y, and BE equals to A plus X. So in conclusion, we got, according to equation number 3, that tangent 30 degrees equals to Y over A plus X. I'll repeat again. According to equation number 3, tangent 30 degrees equals to Y over A plus X. According to equation number 1, Y equals to X times tangent 80 degrees. And according to equation number 2, A equals to X tangent 80 degrees over sinus theta. So we will substitute Y and A by their values from equation number 1 and equation number 2. And we will get that according to equation number 3, tangent 30 degrees equals to Y is equal to X times 80 degrees according to equation number 1 over A according to equation number 2 equals to X tangent 80 degrees over sinus theta, and we must also add X to this equation. Actually, we will add X sinus theta, we will multiply X by sinus theta, and then we will divide it by sinus theta, so we change nothing, it still will be X, in order to have a common factor with this expression. Here we will move sinus theta, that it is in the denominator, to the numerator, and we will get that according to equation number 3, tangent 30 degrees equals to X tangent 80 degrees times sinus theta over X tangent 80 degrees plus X sinus theta. So here we have X in the numerator and we have X in the denominator of this side of equation number 3, so X will get cancelled, and we also know that tangent 30 degrees equals to 1 over square root of 3, that equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta So here we will cross multiply equation number 3, and we will get that according to equation number 3, we have here in this side of equation number 3 tangent 80 degrees plus sinus theta. In the other side of equation number 3 we have tangent 80 degrees times sinus theta. So here we will subtract from equation number 3 sinus theta, and we will get that according to equation number 3, tangent 80 degrees equals to tangent 80 degrees times sinus theta minus sinus theta. So here we will take out sinus theta as a common factor from this side of equation number 3, and we will get that according to equation number 3, tangents 80 degrees. So here we will take out sinus theta as a common factor, and what we will have from this expression, after we took from it sinus theta as a common factor, what is left, it is, so here we have also square root of 3, of course. It's actually square root of 3, and here also it is square root of 3, so because we cross multiplied, so it is actually sinus theta, and inside the brackets we have square root of 3 times tangents 80 degrees. And what is left from minus sinus theta after we took sinus theta as a common factor? What is left? It is actually minus 1. So here we will divide this equation number 3, by square root of 3 times tangent 80 degrees minus 1, and we will get that according to equation number 3, sinus theta will be equal to tangents 80 degrees over square root of 3 times tangents 80 degrees minus 1. So here we have tangents 80 degrees, and we know that tangents 80 degrees equals to sinus 80 degrees over cosinus 80 degrees, so we substitute tangents 80 degrees by sinus 80 degrees over cosine 80 degrees, both in the numerator and also in the denominator. Okay, and we will get that according to equation number 3, that sine theta equals to sine 80 degrees over cosine 80 degrees over square root of 3, and tangents 80 degrees is sine 80 degrees over cosine 80 degrees. And we'll substitute minus 1 by minus cosine 80 degrees over cosine 80 degrees in order to have a common factor with this expression. So it is minus cosine 80 degrees over cosine 80 degrees, that is actually minus 1. So here we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled, and what is left from equation number 3, after we cancel cosine 80 degrees, what is left, it is actually in this side of equation number 3 we have sinus theta, and in the other side of equation number 3 we have sinus 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees, and here we will multiply the denominator on this side of equation number 1 by 2, and then we will divide it by 2. It is allowable to multiply by 2 and divide by 2 any expression, so we will do it because we change nothing actually, and we will get that sinus theta equals to sinus 80 degrees over, so we will multiply the denominator by 2 and then we will divide it by 2. So it is 2 times square root of 3, then we will divide square root of 3 by 2, so we change nothing, times sine 80 degrees. So after we multiply the denominator by 2, we will divide it by 2, so it will be cosine 80 degrees over 2. So according to equation number 3, we actually got that sine theta equals to sine 80 degrees over 2 times sine 80 degrees. And we know that square root of 3 over 2 is cosine 30 degrees, so we'll substitute square root of 2, square root of 3 over 2 is cosine 30 degrees, so we'll substitute square root of 3 over 2 by cosine 30 degrees, minus cosine, here 1 over 2 is sine 30 degrees, so we'll substitute 1 over 2 by sine 30 degrees, and it is times cosine 80 degrees. So actually the expression in the denominator is very similar to the trigonometric identity that states that sine A times cosine B equals to sine B times cosine A, that equals to sine A minus B. So according to this trigonometric identity, we can substitute our expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we'll do it now, and we get that according to equation number 3, sine theta equals to sine 80 degrees over 2, and we will substitute this expression by sine A minus B, that is to say by sine A is 80 degrees and B is 30 degrees, so it is actually sine 80 degrees minus 30 degrees. So in conclusion, we found out that according to equation number 3, sine theta equals to sine 80 degrees over 2 sine 80 degrees minus 30 degrees is 50 degrees. Okay? And we actually substituted the expression that we have in the denominator by sine A minus B, that is actually sine 80 degrees minus 30 degrees. So we got that according to equation number 3, sinus theta equals to sine 80 degrees over 2 sine, again 80 degrees minus 30 degrees is 50 degrees, so it is sine 50 degrees. So in conclusion, we found out that according to equation number 3, sine theta equals to sine 80 degrees over 2 sine 50 degrees. So here we'll use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. And we'll get that here sine theta equals to, again, we'll use the trigonometric identity that's stated in order to simplify sine 80 degrees. So according to this trigonometric identity, the value of sine 80 degrees equals to 2 sine 40 degrees times cosine 40 degrees and we also have to divide it by 2 sine 50 degrees. Two over 2 is 1, so 2 will get cancelled. And according to the trigonometric identity that states that sinus alpha equals to cosinus 90 degrees minus alpha, we will get that the value of sinus 50 degrees will be equal, according to this trigonometric identity, to cosine 90 degrees minus alpha, that is 50 degrees. So, and 90 degrees minus 50 degrees is 40 degrees, so we got that sine 50 degrees equals to cosine 40 degrees. So we actually can substitute sine 50 degrees in equation number 3 by cosine 40 degrees. So we will do it now, and we will get that according to equation number 3, sine theta equals to sine 40 degrees times cosine 40 degrees over sine 50 degrees, and we'll substitute sine 50 degrees by cosine 40 degrees. So here we have cosine 40 degrees in the numerator, and we have cosine 40 degrees in the denominator, so cosine 40 degrees will get cancelled. And we found out that, according to question number 3, that sine theta equals to sine 40 degrees. That is to say, theta equals to 40 degrees. And actually, angle theta is angle ADC, the angle that we are looking for. So angle ADC that equals to angle theta equals to 40 degrees. Okay, so according to the second method, we found out that the angle that we are looking for, that is actually angle theta, equals to 40 degrees, and we actually found out that in both methods, in the first method and also in the second method, the value of angle ADC is 40 degrees. So now I will summarize the lecture. Actually, we wanted to find out the value of angle ADC. We found the value of angle ADC in two different methods. In the first method, we defined AC as A, we defined BC as B, and according to what is given us in the question, AD equals to BC. From one side, AD equals to BC, but from the other side, according to our definition, BC equals to B. So from this equation, AD equals to BC equals to B, we will derive that AD equals to B. So AD here equals to B. Then I presented to you the law of sines. According to the law of sines, in any triangle, if we have this triangle, triangle ABC, we know that side AB equals to C units in its length, side AC equals to B units in its length, and side BC equals to A units in its length. Then according to the law of sines, A over sine alpha equals to B over sine beta equals to C over sine C. Okay? We will derive from this formula that A over sine A equals to B over sine B, and we can implement the law of sines in our drawing. So we implemented the law of sines in triangle ABC. I copied triangle ABC in this new page. We know that angle ABC equals to 30 degrees, angle ACB equals to 100 degrees according to what is given in the question, and we have to find out the value of this angle. So we define this angle as x, and we know that the sum of the angles in any triangle is equal to 180 degrees, so the sum of the angles in triangle ABC equals to 180 degrees. That is to say, angle x plus this angle that is 30 degrees plus this angle that is 100 degrees must be equal in total to 180 degrees. Here we subtracted 120 degrees from this equation, and we got that angle x equals to 118 degrees minus 120 degrees. It is actually 50 degrees. So we found out that this angle BAC equals to 50 degrees. And again, we know that AC equals to A and BC equals to B. That is according to our definition. So now we can implement the law of sines in this triangle ABC, after we know all the angles of this triangle. According to the law of sines, A over sine 30 degrees will be equal to B over sine 50 degrees. So this is equation number 1. Here we divided equation number 1 by B, and then we multiplied by sine 30 degrees, and we got that A over B equals to sine 30 degrees over sine 50 degrees. Then we focused on triangle ADC, but before that we have already found out that angle BAC, this angle equals to 50 degrees. So if we define angle DAB as theta, then angle CAD must be equal to 50 degrees minus theta, because this angle in total equals to 50 degrees. Therefore, the sum of those two angles must be equal to 50 degrees. And indeed, angle theta plus 50 degrees minus theta will be equal to 50 degrees. And then we focused on this triangle ADC. So we know that this angle equals to 50 degrees minus theta, this angle equals to 100 degrees, and this angle is the missing angle, so we defined it as angle Y. And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ADC, the sum of the angles must be equal to 180 degrees, so angle Y plus 100 degrees plus this angle that is 50 degrees minus theta, in total they must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we got that Y minus angle theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we added angle theta to this equation, and we found out that angle Y equals to 30 degrees minus theta, so the missing angle is 30 degrees plus theta. So the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. Then we implemented the law of sines in this triangle ADC. According to the law of sines, A over sinus 30 degrees plus theta will be equal to B over sinus 100 degrees. This is according to equation number 2. So here we divided this equation number 2 by B, and then we multiply it by sinus 30 degrees plus theta, and we got that A over B according to equation number 2 equals to sinus 30 degrees plus theta over sinus 100 degrees. This is according to equation number 2, but according to equation number 1, we've already found out that A over B equals to sinus 30 degrees over sinus 50 degrees. So we can create the equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So this is actually equation number 3, and A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and A over B according to equation number 2 is sinus 30 degrees plus theta over sinus 100 degrees. Here we cross multiply this equation number 3. We know that sinus 30 degrees is 1 over 2, so it is actually 1 over 2 times sine 100 degrees times sine 30 degrees plus theta times sine 50 degrees. We use the trigonometric identity that sinus 2a equals to 2 sine a cosine a in order to simplify sinus 100 degrees. According to this trigonometric identity, we will get that sinus 100 degrees equals to 2 sinus 50 degrees times cosine 50 degrees. So here 2 over 2 is 1, so 2 will get cancelled. In the other side of the equation, we have sinus 30 degrees plus theta times sine 50 degrees. We have sine 50 degrees on both sides of the equation, so sine 50 degrees will get cancelled. And we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. We use the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha in order to find out the value of cosine 50 degrees. The value of cosine 50 degrees according to this trigonometric identity will be equal to sine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So we actually found out that cosine 50 degrees equals to sine 40 degrees. So here we can substitute here cosine 50 degrees by sine 40 degrees. We did it here, and we got that sine 40 degrees equals to sine 30 degrees plus theta according to equation number 3. Sine 40 degrees equals to find sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we subtracted 30 degrees from this equation number 3, and we got that angle theta equals to 10 degrees. So here angle theta equals to 10 degrees. And the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. So 30 degrees plus theta, that is 10 degrees, is 40 degrees. So we found out that the angle that we are looking for, angle ADC equals to 30 degrees plus theta, and theta is 10 degrees. So angle ADC equals to 30 degrees plus 10 degrees, that is to say angle ADC equals to 40 degrees. So we found out that angle ADC equals to 40 degrees according to the first method. Then I presented to you how to find out the value of this angle ADC according to the second method. According to the second method, we actually defined side BC as A, and we know that BC equals to AD according to what is given as the question, and according to our definition, BC equals to A. So from this equation, we will derive that AD also equals to A. So we can write here that AD equals to A. Then we extended BC by a straight line, and then we, from point A we drew perpendicular to the extended BC. So this angle is 90 degrees and this angle is also 90 degrees. And we define the intersection point from the perpendicular from point A and the extended BC as point E. Then we found the value of this angle. We know that BC is one side of triangle ABC, therefore it must be a straight line. And when we extended the straight line BC by a straight line, we got line segment BE that will be still a straight line. And we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if we focus on the straight line BE on the upper side at point C, the sum of the angles must be equal to 180 degrees. That is to say 100 degrees plus this angle, that is angle Y, must be equal to 180 degrees. So I will repeat again that BE is a straight line, and the sum of the angles on one side of a straight line must be equal to 180 degrees. So on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. That is to say 100 degrees plus Y must be equal to 180 degrees. We subtracted 100 degrees from this equation, and we got that angle Y equals to 180 degrees minus 100 degrees, that is to say angle Y equals to 80 degrees. So we found out that this angle Y equals to 80 degrees. Then we focused on the right triangle ACE. On this right triangle, we know that tangents 80 degrees equals to AE over CE. In the right triangle ACE, tangents 80 degrees equals to AE over AC. But AE equals to Y according to our definition, and CE also equals to X. So we got the tangents 80 degrees equals to Y over X. Here we multiply the equation number 1 by X, and we found out that Y equals to X times tangents 80 degrees. Then we focused on the right triangle ADE. We defined angle ADE, the missing angle, the angle that we are looking for is angle theta. And in the right triangle ADE, we know that tangents, that sinus theta equals to AE over AD. In the right triangle AD, we know that sinus theta equals to AE over AD, but AE equals to Y, and AD equals to A, so we found out actually that sinus theta according to equation number 2 equals to Y over A. Then we multiplied this equation number 2 by A, and then we divided by sinus theta, and we got that A equals to Y over sinus theta. And according to equation number 1, Y equals to X times tangents 80 degrees. So we substituted Y by X times 80 degrees, and we got that A equals to X times 80 degrees over sinus theta. And according to equation number 1, Y equals to X times tangents 80 degrees. Then we focused on the right triangle ABE. Here we know that tangents 30 degrees equals to AE over BE. Again, in the right triangle ABE, we know that tangents 30 degrees equals to AE over BE. AE equals to Y, and BE equals to A plus X. So in conclusion, we found out that tangents 30 degrees equals to Y over A plus X. Here we substituted Y by the value of Y from equation number 1, that is actually X tangents 80 degrees, and we substituted A by the value of A from equation number 2, that is actually X tangents 80 degrees over sinus theta. And then we have also to add X. we actually multiplied x by sinus theta, and then we divided by sinus theta, so we changed nothing. And we did this in order to have a common factor with this expression. Here we moved sinus theta from the denominator to the numerator, and we got that tangent 30 degrees equals to x times tangent 80 degrees times sine theta over x times tangent 80 degrees plus x sine theta. Here we have x in the denominator and we have x in the numerator, so x will get cancelled. And we know that tangent 30 degrees equals to 1 over square root of 3. So in conclusion, we got that according to equation number 3, 1 over square root of 3 equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we cross multiply this equation number 3, and we found out that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sine theta. Here we subtracted sine theta from this equation number 3, and we got that according to equation number 3, tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Then we took a common factor of sinus theta from this side of equation number 3, and we got that tangent 80 degrees equals to sinus theta, and inside the brackets we have here square root of 3 times tangent 80 degrees minus 1. Okay? Then we actually divided this equation number 3 by square root of 3 tangent 80 degrees minus 1, and we got that according to equation number 3, sinus theta equals to tangent 80 degrees over square root of 3 tangent 80 degrees minus 1. We know that tangent 80 degrees equals to sinus 80 degrees over cosine 80 degrees, and it is divided by square root of 3 tangent 80 degrees, and tangent 80 degrees equals to sinus 80 degrees over cosine 80 degrees, and we also have to subtract 1, so we substituted 1 by minus cosine 80 degrees over cosine 80 degrees in order to have a common factor with this expression. Here we have cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled, and we left only with sine theta that equals to sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. Okay, so here we multiplied the denominator by 2, and then we divided by 2, and we got that sinus theta equals to sine 80 degrees, so we multiplied the denominator by 2, and then we divided by 2, and we got square root of 3 over 2 times sinus theta equals to minus cosine 80 degrees over 2. And then we have cosine sine theta equals to sine 80 degrees times 2, and here we have sinus 80 degrees, and we substituted square root of 3 over 2 by cosine 30 degrees, because cosine 30 degrees equals to square root of 3 over 2, and here we have 1 over 2, so we substituted 1 over 2 by sine 30 degrees, and we have also to multiply it by cosine 80 degrees. So this expression, sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that cosine A, that sine A times cosine B minus sine B times cosine A equals to sine A minus B. So according to this trigonometric identity, we can substitute our expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we did it, and we got that sine, according to equation number 3, sine theta equals to sine 80 degrees over 2 sine A minus B. And A minus B is 80 degrees minus 30 degrees. Here we used we know that 80 degrees minus 30 degrees is 50 degrees, so we got that sinus theta equals to sinus 80 degrees over 2 sine 50 degrees. Here we use the trigonometric identity that sinus 2a equals to 2 sine a cosine a in order to simplify sine 80 degrees, and according to this trigonometric identity the value of sinus 80 degrees will be equal to 2 sine 40 degrees cosine 40 degrees divided by 2 sine 50 degrees. 2 over 2 is 1, so 2 will get cancelled, and we have cosine 50 degrees. We actually use the trigonometric identity that sine alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So we actually got that sine 50 degrees equals to cosine 40 degrees. So we actually can substitute sine 50 degrees here. We can substitute sine 50 degrees that we have here by cosine 40 degrees, because of the fact that sine 50 degrees equals to cosine 50 degrees. So we did it. We substituted sine 50 degrees by cosine 40 degrees, and we got that sine theta equals to sine 40 degrees times cosine 40 degrees over cosine 40 degrees. Cosine 40 degrees over cosine 40 degrees is 1, so cosine 40 degrees will get cancelled, and we left only with sine theta that equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees, and theta it is actually angle ADC that equals to 40 degrees. So in both methods, we found out that the angle that we are looking for, that is actually angle ADC, equals to 40 degrees. Okay, thank you very much.